Hello guys. So, as you probably heard about in the last video, we're making a Linux distribution for terminals. Now I wanted to just go over what is a terminal and why is this important. Well, here I've got a bit of a fun mess of hardware. This is because I don't have another case, but I needed this, so I put it on the desk. And it's kind of funny because the last video that I posted is actually encoding. So, I have all this hardware, and I'm going to just quickly go over it, and you'll see why this is relevant later. I've got a 40 gig Max-Tor Diamond Max hard drive. I've got a floppy drive, a CD drive. This isn't even DVD, this is CD, this was made in 2000. 250 watt power supply, a NVIDIA Vanta 16 graphics card. That's a graphics card with only 60 megabytes of memory, video memory, 58K, I'm pretty sure, dial-up modem, PCI dial-up modem, and back sneaking in there is a Realtek 100 base T network card. That is the processor. I know, it's old. It's a 550 megahertz Pentium 3 slot 1 processor with 256 megabytes of PC133 memory. Now, this is important for two reasons. One, I needed just a very basic system for using as a terminal. Two, for testing out this operating system, I wanted to test it out on this because this is very basic hardware. So if it can run fast on this, it should run fast on just about any computer now. Now, I know my desk is, or what I'm using as the desk, is a mess, but let's go over here. I can't record the screen because it's command line, but just give me a second here. This is running Arch Linux. Now, we're probably going to be using Linux from scratch, but if that doesn't completely work out, if something goes wrong there or something, we're going to be basing this terminal off of the thing off of Arch. Now, some of the stuff that's what do you need a terminal? Well, you don't really need a terminal, but if you're controlling a large amount of systems, like say in a cloud or in a server farm or something like that, you should have a system that's specifically built for just monitoring them, providing in-band and out-of-band management, and network diagnosis and stuff like that. So, as you can see, it's this little root to ls. It's just directories. But so what this now, what is in-band and out-of-band management? Because a lot of people don't know this. In-band management is stuff like SSH. SSH is secure shell, which it connects to the server via a secure shell. Telnet, it's older. It's kind of the same thing as SSH, but it's an older form of it, and it's not encrypted. Web interfaces, so like PHPMyAdmin is in-band. Anything that requires the system to be online and connected to the network is in-band management. Now, out-of-band management. What is out-of-band management? Out-of-band management is serial connections. Now, a lot of people actually don't know what serial connections is. And let me give you an example. Just let me move over here. Get my serial cable. This is a serial cable. You don't see them much now, but sometimes you do. Now, if the systems in there for some reason cannot boot up and they are headless, so say if you're in a rack and there's no monitor or keyboard, and there's no KVM or something, how are you going to manage those when they're if you find a fault? Well, you're going to use Serial. What Serial does is you connect it. You don't have these ports on most computers anymore. It's USB, and in that case you need a USB adapter. But the ones down here, these are serial connections. Basically what you do is you plug this into the serial connection, and if you've previously set it up so it forwards it in the BIOS in the target system, this should work. Now, if I want to use that and open a serial connection to this, which is my NAS server, I would plug one end of this into the NAS server and one end of it into the terminal, and then open up serial terminal emulation software such as Minicom. PuTTY does it in Windows. Like, I'll just show you what Minicom is. Minicom. Typing with one hand. Control A and Z. Now, Minicom is for serial connections and serial modems for dial-up. But it's kind of like SSH. You open up the connection and it will give you a shell. But it doesn't just give you the shell that shows like the login console. It shows everything. It shows the post-process. It shows the you can get into the BIOS. It shows everything, and then that way you can manage it. Now, a system like this will use Serial. Now, the Terminal Linux will also have a serial emulator, such as Minicom or some other one. It's probably going to be Minicom to interface with these things. It also allows you to interface with most switches and routers, because actually a lot of routers and firewalls, including that one over there, use a serial cable for their management interface. That was a lot of explaining. So it's going to have those. It's also going to have network managing tools. So if you have a network that is, say, like I do, which goes from that switch over there to my servers, you're going to want to monitor what's going on between that switch and those servers. So you're going to do that with what's called a passive network tap, or if you have a gigabit connection, you're going to need an active Ethernet tap. And what that does is it basically takes the packets that are flowing between the two portions and puts them into the interface card there. And using a program such as TCP dump, in command line it's tshark, or any other packet sniffer, you can see the flow going across. Now, that's what this is going to have. It's going to have a suite of tools for network diagnosing. I'm going to try and put in TCP dump, tshark, just if people have a preference, and probably also snarf, which is another one, and what's it called? An intrusion detection system. So this is also going into security. What's it called again? Snort. Because what Snort does is Snort acts as a detection system. So if you think that something is a little suspicious, it's going on, you can figure that out. So we've got the two things. We've had the in and out of band management tools. So the in and out of band management tools include SSH, Telnet, and Minicom, and a few others. I haven't finalized stuff yet about that. And then also the network management. It's going to have the network management tools. But then I'm also going to put in a few development tools. So you can do more than just interface. Oops. Come on this system. Yes. I'm going to be putting in various programming tools. So it's going to include the Java compiler, the GDK. It's going to probably include Open COBOL for COBOL development, if any of you guys do that. It's going to include Python, Perl. It's going to include an entire suite of programming tools. No worries about that. Now, please bear in mind also that it's going to be completely command line. This is to, for one, allow it to run on systems with very, very low spec graphics cards, but it also allows systems to run on systems such as with like almost very little processing power. So like say a Raspberry Pi or a BeagleBone or something like that. So like for example, if I do htop, I've basically built a very base with this right now with Arch. With htop, it's only using 24 megabytes of memory, which is very, very, very little. And I've got IRC running, which is the IRC client, and a few other stuff. So it's going to have the programming interface. So it's going to have GCC. It's going to have the compilers and stuff like that. And then for editors, I'm going to both include Vi and Nano, because I know some people prefer Vi, some people prefer Nano. I prefer Nano, but that's just it's personal preference. And what else? It is going to have htop, so you're going to be able to see your own stuff, because htop is not included on some things. I'm also going to be including probably some of our own software, which I will not tell you about yet. And that's about it, really. It's a very minimal base operating system, and the beauty about it is that because it's Linux and because it's command line, you'll have the ability to install your own software yourself, so you can completely customize it to your own liking. If you want a graphical user interface, you can install a graphical user interface. I don't recommend it, but you can. So basically what this is, in a nutshell, what this is based for is for people who want to control, who have servers and stuff like that, and want to control major systems including mainframes, so like System Z, mainframes, things like that. I want to get my hands on one of those things. I've been dying to play around with ZOS. A servers, so if you run Minecraft servers, but if you run a lot of them, so, if you're not running a lot of services and a lot of servers, then you don't really need something like this. You can use a laptop like that, or you can use you can run your things in Screen, which is what I do a lot of the times. The Minecraft servers ran in Screen. It's for big racks of servers, cloud computing too, to monitor the resources and monitor the traffic flow and stuff like that. So that about wraps it up. I know it's been a very, very long video. I apologize for that, but there's a lot of explaining. I will be making another video soon on Termnix and Termnix, which are the the server distribution and the desktop distribution. This one will also be able to, I'm going to try and see if I can get ARM compatibility. So if you do have a Raspberry Pi or another one of those ARM devices, this will be able to run on it. Which is nice because, let's face it, who wants to have a really, really big, like a tower, just for a terminal? You could use a Raspberry Pi, which actually is what I intend on doing, because I love those things. But other than that, that's about it. So, thanks for watching this video, and subscribe for more computer videos in the future.